Hello students. Now, after learning about integration and different methods of integration, let us discuss about fundamental theorem of integral calculus. The first theorem of integral calculus states that let the area function be defined by a of x is equal to integral a to b f of x dx for all x greater than or equal to a, where the function f is assumed to be continuous on closed interval a b. Then a dash x is equal to f of x for all x belonging to the closed interval a b. And the second fundamental theorem of integral calculus says that let f be a continuous function of x defined on the closed interval a b, and let f be another function such that d by dx of f of x is equal to f of x for all x in the domain of f. Then integral a to b f of x dx is equal to f of x plus c with lower limits and upper limits as a and b, that is equal to f of b minus f of a. This is called the definite integral of f over the range a b, where a and b are called the limits of integration, a being the lower limit and b the upper limit. Now, let us solve some examples using fundamental theorem of integral calculus. Evaluate the following integral 2 to 3 x square dx using second fundamental theorem of integral calculus. For the solution, let I be equal to integral 2 to 3 x square dx, since integral x square dx is equal to x cube upon 3, that is equal to f of x. Therefore, by the second fundamental theorem, we get I is equal to f of 3 minus f of 2, that is equal to 27 upon 3 minus 8 upon 3. On solving, we get 19 upon 3 as the answer. Now, one more example. Evaluate the following integral 1 to 2 x dx upon x plus 1 into x plus 2. For the solution, using partial fractions, we get x upon x plus 1 into x plus 2 is equal to minus 1 upon x plus 1 plus 2 upon x plus 2. So, integral x dx upon x plus 1 into x plus 2 is equal to minus log of modulus x plus 1 plus 2 into log of modulus x plus 2, that is equal to f of x. Therefore, by second fundamental theorem of calculus, we have integral is equal to f of 2 minus f of 1, that is equal to minus log 3 plus 2 log 4 minus log 2 plus 2 log 3, that is equal to minus 3 log 3 plus log 2 plus 2 log 4. On solving, we get log of 32 upon 27. Now, after solving the examples, let us look into two important remarks. First remark is about second fundamental theorem. The second fundamental theorem is very useful because it gives us a method of calculating the definite integral more easily without calculating the limit of a sum. And the second remark is the crucial operation in evaluating a definite integral is that of finding a function whose derivative is equal to the integrand. Now, let us discuss about evaluation of definite integral by substitution. To evaluate integral a to b f of x dx by substitution, the steps could be as follows. First step, consider the integral without limits and substitute y is equal to f of x or x is equal to g of y to reduce the given interval to a known form. Second step is to integrate the new integrand with respect to the new variable without mentioning the constant of integration. Third step, resubstitute for the new variable and write the answer in terms of the original variable. Now, fourth step is find the values of answers obtained in step 3 at the given limits of integral and find the difference of the values at the upper and lower limits. Let us illustrate this by an example. Evaluate integral 0 to 1 tan inverse x upon 1 plus x square dx. For the solution, to evaluate integral 0 to 1 tan inverse x upon 1 plus x square dx, let t be equal to tan inverse x, then dt is equal to 1 upon 1 plus x square dx. The new limits are when x is equal to 0, t is equal to 0, and when x is equal to 1, t is equal to pi upon 4. Thus, as x varies from 0 to 1, t varies from 0 to pi upon 4. Therefore, integral 0 to 1 tan inverse x upon 1 plus x square dx is equal to integral 0 to pi upon 4 t dt, that is equal to t square upon 2 within limits pi by 4 0, that is equal to half of pi square upon 16 minus 0. On simplification, we get the answer as pi square upon 32. Let us solve one more example. Evaluate minus 1 to 1 integral 5 x raised to 4 into square root of x raised to 5 plus 1 dx. For the solution, first we transform the integral and then evaluate the transformed integrand with new limits. Let t be equal to x raised to 5 plus 1, then dt is equal to 5 x raised to 4 dx. Note that when x is equal to minus 1, t is equal to 0, and when x is equal to 1, t is equal to 2. Thus, as x varies from minus 1 to 1, t varies from 0 to 2. Therefore, integral minus 1 to 1 5 x raised to 4 into square root of x to the power 5 plus 1 dx is equal to integral 0 to 2 square root of t dt, that is equal to 2 upon 3 into t raised to 3 upon 2 within limits 0 to 2. On applying limits, we get 2 upon 3 into 2 raised to 3 upon 2 minus 0 raised to 3 upon 2, which on simplification gives 2 upon 3 into 2 root 2, and thus we get the answer as 4 root 2 upon 3. Now, let us look into some properties of definite integrals. These properties are useful in evaluating the definite integrals more easily. First property, integral a to b f of x dx is equal to integral a to b f of t dt. Second property is integral a to b f of x dx is equal to minus of integral b to a f of x dx, or integral a to a f of x dx is equal to 0. Third property says integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. Fourth property is integral a to b f of x dx is equal to integral a to b f of a plus b minus x into dx. Fifth property says integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. And sixth property is integral 0 to 2a f of x dx can be written as integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. And seventh property says integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x and 0 if f of 2a minus x is equal to minus f of x. And the eighth property says integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f is an even function, that is if f of minus x is equal to f of x. And another property is integral minus a to a f of x dx is equal to 0 if f is an odd function, that is if f of minus x is equal to minus of f of x. Now, let us solve some examples using these properties. First example, evaluate integral minus 1 to 2 modulus x cube minus x into dx. For the solution, we note that x cube minus x is greater than or equal to 0 on the interval minus 1 0 and x cube minus x is less than or equal to 0 on the interval 0 1 and x cube minus x is greater than or equal to 0 on the interval 1 comma 2. So, by property 3 we write integral minus 1 to 2 modulus x cube minus x dx is equal to integral minus 1 to 0 x cube minus x into dx plus integral 0 to 1 minus of x cube minus x into dx plus integral 1 to 2 x cube minus x into dx, that is equal to integral minus 1 to 0 x cube minus x into dx plus integral 0 to 1 x minus x cube into dx plus integral 1 to 2 x cube minus x into dx. On solving, we get x raised to 4 upon 4 minus x square upon 2 with limits minus 1 and 0 plus x square upon 2 minus x raised to 4 upon 4 with limit 0 and 1 plus x raised to 4 upon 4 minus x square upon 2 with limits 1 and 2. After applying limits, we get minus of 1 upon 4 minus 1 upon 2 plus 1 upon 2 minus 1 upon 4 plus 4 minus 2 minus 1 upon 4 minus 1 upon 2. On simplification, we get minus 1 upon 4 plus 1 upon 2 plus 1 upon 2 minus 1 upon 4 plus 2 minus 1 upon 4 plus 1 upon 2, and thus we obtain 11 upon 4 as the answer. Let us solve one more example. Integral minus pi by 4 to pi by 4 sin square x dx. For the solution, we observe that sin square x is an even function. Therefore, by property 8, we get integral minus pi by 4 to pi by 4 sin square x dx is equal to 2 into integral 0 to pi by 4 sin square x dx, that is equal to 2 into integral 0 to pi by 4 1 minus cos 2x upon 2 into dx, that is equal to integral 0 to pi by 4 1 minus cos 2x into dx, that is equal to x minus 1 upon 2 sin 2x with limits 0 and pi by 4, that is equal to pi upon 4 minus 1 upon 2 sin pi upon 2 minus 0. On simplification, we get pi upon 4 minus 1 upon 2. So, students, in this chapter, we studied about integration, different methods of integration, definite integrals and fundamental theorem of integral calculus. Thank you.